Namaste everyone, I am Gyan and you are watching the session 20 of Java and Web, Multithreading in Java. In this video, we are going to study about the StampedLock in Java. The StampedLock is a different implementation of reader-writer lock. The StampedLock is faster than the conventional reader-writer lock and introduced with Java 8. So if you are using the Java version 7 or lower versions of Java, you will not be able to use the StampedLock. StampedLock class is better to use if reader threads are much higher than the writer threads. That is called read contention. If there are very large number of reader threads than the writer threads, then it is better to use the stamped lock instead of read-write lock, the conventional read-write lock. In such cases, when the reader threads are much more than the writer threads, conventional read-write lock can lead to starvation or can be very slow. There is only one constructor in the stamped lock class, that is the default constructor. There is nothing like fairness, which we have studied with earlier locks. There are three modes of locking present in the stamped lock: writing, reading, and optimistic reading. The other locks has only two modes of locking, writing and reading. But there is one more locking mode present in the stamped lock, and that is called optimistic reading. First come to the writing mode locking. We have three methods here: write lock, try write lock, and try write lock with arguments. The write lock method acquires lock exclusively. The working of this write lock method is same as the writing locks of earlier lock classes. The write lock method blocks the thread until available. The write lock method is a public method which returns long. The long value returned by the write lock method is a stamp. What this stamp does, we will see in a while. The second lock is try write lock method. We already have seen such methods like try lock with the earlier classes. The try write lock method is a public method which returns long. The try write lock method acquires lock if it is immediately available. Otherwise, returns 0 if the lock is not immediately available. And of course, the try write lock method is a public method which returns long. After that, we have try write lock method with two arguments, one of type long and other one of type time unit. We already have seen the use of time unit. If the time unit is second and the time is 2, that means if the lock is not available, then the thread will wait for the lock for 2 seconds. And after that, the thread will give up acquiring the lock. Here in this case, if the lock is not available, then the thread will give up acquiring the lock immediately. But here in this case, the thread will give up acquiring the lock after this much time. Of course, the try write lock method is a public method which returns a long. All methods means all the methods in the writing mode, all the methods in the reading mode, and all the methods in the optimistic reading mode returns a stamp value, that is a value of type long that contains a version and a mode like reading and writing. Let's use the writeLock method. Here we have the Java file CreateThread.java. In the CreateThread.java, we are importing all the classes from the package java.util.concurrent.locks, and the class StampedLock is present in the same package. The file CreateThread.java contains the class CreateThread, which contains the method main. In the method main, we are creating a new object of type StampedLock, whose reference will be stored into the reference variable lock. After that, we are creating a new array of class MyThread, the array of size 5. Then after, we are initializing each element of this array, and we are starting all the threads. We have passed the names of the threads like T0, T1, T2, T3 and T4 and reference to this stamped lock so that all the threads should work on the same lock reference. We have another Java file MyThread.java, and here is the class MyThread, which extends the class thread. In the constructor of the class MyThread, we have initialized the reference variable lock. Then after in the run method, we have called the writeLock method by using the reference variable lock. And we have printed the thread name got the writeLock. After getting the lock, the thread will go for a sleep for 5000 milliseconds, means 5 seconds. After that, we have called unlock write by using the reference variable lock. There are three types of unlocking present in the class StampedLock: unlock read, unlock write, and only unlock. If you are sure enough that the lock you are going to unlock is a write lock, then you should call unlock write with stamp as its argument, the same stamp which was returned by the write lock method. Call to the unlock write has been blocked in the try catch, just because if you are calling the unlock write on a reference variable of type lock which does not have any write lock, then in that case this statement will throw illegal monitor state exception. That's why in the catch block we have printed the name of the thread, the stack trace, and did not get the lock. After that, in the finally block we are printing the name of the thread finished. Of course, we can print here the value of stamp or the value of lock. Both we can print here, and we will print while executing this code. So let's execute this code practically. Open CreateThread.java, and this is the same code as we have seen. Open MyThread.java, and this is the same code as we have seen. Let me print here the value of stamp. So here you will see the long number returned by the writeLock method. Now try to compile this code. Java C, CreateThread.java, and MyThread.java. Compiles fine. Now run it. Java create thread. The program executes fine. Each thread is sleeping for 5 seconds. That's why the program is taking time to finish. And you can see different threads has different values of stamp variable. All the threads got finished. Now let's make some changes in the code, and let's write here the lock reference variable instead of stamp. The lock reference variable. Compile these two codes. Compiles fine. Now execute it. It's executing fine, and at this time you can see the value of the lock reference variable. The name of the lock has code, and it is printing write locked. So hopefully you are getting my points. This code is similar to the previous one. Nothing has been changed. Instead of, we are calling try write lock instead of lock. And we know that one thread is going to sleep for 5000 milliseconds. So the situation is one thread got the lock and having a sleep for 5000 milliseconds. In between, 4 other threads will come and try to get a write lock. But they will not succeed getting the lock, because when they try, the lock was acquired by the first thread which first got the lock. So other 4 threads will be give up acquiring the lock, because what they are calling is try write lock method. So after that, what will happen here is the one thread which got the lock initially will easily call the unlock write, while the other threads will cause exception while calling the unlock write method. So other 4 threads will cause illegal monitor state exception because they did not get the chance to acquire a lock. Therefore, calling unlock write method for those 4 threads will cause exception. And those 4 threads which did not get a chance to acquire a lock will print the name of the thread stack trace did not get the lock. And finally, all the threads will print the thread name and the value of a stamp. Let's try this code practically. Let's open MyThread.java and just make only one change. Instead of calling here write lock, call here try write lock, and rest of the outputs will be same. Here let's print stamp, and in the last line our code will print finished. We are not going to print stamp here as we have seen in the slide. What we are printing here is finished. So let's try to execute these two codes. Java C, CreateThread.java, MyThread.java. Compiles fine, now run it. Java create thread. It executes fine. And you can see 4 threads did not get the lock. The values, the stamp values for these 4 threads are 0. Only T0 got the lock and having a stamp value. T0 finished. But other 4 threads, T1 to T4, caused illegal monitor state exception and did not get the lock. There are 3 kinds of unlocking present in the stamp lock method: unlock write, unlock read, and unlock. All the methods except a long argument. The value returned by the lock method should be passed as an argument to the unlock methods. If you know that the lock is acquired by the write lock, then you can call unlock write. If you know that a read lock has been acquired by the thread, then you can call the unlock read method. But if you are not sure that which type of lock is acquired by the thread, then you can just call unlock method. This is not efficient to call unlock method because then the thread has to inquire on itself that which type of lock it has gained to unlock it. But as a programmer, if you know that what kind of lock it is, then try to call the specific unlock method. All the unlock methods in the StampedLock class are public methods and return void. Now coming to the reading mode locks. Similar to the writing mode locks, we have three reading mode locks: read lock, try read lock, and try read lock with arguments. The read lock method acquires a non-exclusive lock, and the thread which wants the read lock will be blocked until the lock is available. If you call the try read lock, then the thread which is calling try read lock will give up acquiring the lock if the lock is not immediately available. In these three cases, if the threads get the lock successfully, then the threads will return corresponding stamp, means a long number. But in the try read lock method, if the threads are not able to acquire the lock successfully, then they will return a 0. In the third case, if the lock is not available, then the thread will wait up to this time. If before this time the lock becomes available, then the thread will acquire the lock, otherwise the thread will give up acquiring the lock. We already have seen such methods in the writing mode. So let's use the read lock method. Here in this case, the code is similar to the previous one. Only difference is that we are calling the read lock method by using the reference variable lock, and we are calling the unlock read method instead of the unlock write method. Let's execute this code practically. Open MyThread.java and just write here read lock instead of try write lock. Just write here read lock. Now coming below, type here unlock read. Rest of the codes are same. Here we are printing the value of stamp, and of course we will print the value of lock also. Now compile this code practically. Java C, CreateThread.java, MyThread.java, compiles fine, now run it. It executes fine, and you can say all the threads got the lock at the same time. They have different values of stamp, and after that they all finished. Of course, here we are printing the write lock. We have not changed the string in the code, but what we are requiring is the read lock. Now let's print the value of lock. Let's print the value of the reference variable lock instead of stamp, lock, and write here read lock because it's not good looking. When you are working on the read lock but printing a write lock, that's not good. Write here read lock. Try to compile this code. Java C, CreateThread.java, MyThread.java, compiles fine, now run it. It runs fine, and see here the value of lock has called the toString method of the StampedLock class, and it is printing the name of the class, hash code, and how many read locks are available. 5 threads have got the read lock. So hopefully you are getting my points. In the similar way, you can call the try read lock method. Let's call here try read lock method, but that will not be effective because a thread having read lock cannot stop other threads having read lock to acquire the lock, because a thread having read lock cannot stop other threads which want to acquire the read lock. So try read lock method will be effective if we have multiple threads, some are reading and some are writing. But here in this case, the try read lock will not be effective because everyone will get the lock because no one wants the writing lock. That's why our program will execute very fine, similar as above. The other mode is optimistic reading, and this is the difference between StampedLock and other lock classes. There are two methods in optimistic reading: try optimistic read and validate. The method try optimistic read is a public method which returns long, and the validate method is a public method which returns boolean. One thing you should remember, the try optimistic read method never gets a lock for a thread. What will happen here? When we call the try optimistic read, the method will return a validation stamp. And this stamp should be validated later by using the validate method. If I try to say you about optimistic reading on this slide, then you will get confused. So let's jump to the example and try to understand the optimistic reading with clarity. Remember that there is no unlock method corresponding to the try optimistic read method because the try optimistic read method never gives you a lock. So how the try optimistic read method works? Let's see it. So we have two files, CreateThread.java and MyThread.java. CreateThread.java is similar as we have seen in earlier codes, and we have MyThread.java. The run method in the MyThread.java has significant difference from earlier slides. Let's see the execution of run method for a thread. We have a long variable stamp which has been initialized to 0. Then after we are calling the try optimistic read method by using the reference variable lock, which returns a long value stamp. Calling here try optimistic read never gives you a lock. So here this is not a lock. In the next statement, the program will print the name of the thread, optimistic read stamp, the value of the optimistic read stamp. After that, we have multiple lines of codes, which has not been shown here. And we have nothing locked here. Then after, in the argument of the if block, we are calling the validate method with stamp as its argument. The same stamp which was returned by the try optimistic read method. In between this line and this line, if a writer thread got a writing lock, then the validate method will return false and the overall expression will become true. But if in between this line and this line, no writer thread ever got a lock, then the validate method will return true and the overall expression will become false. The idea is that to validate if a writer has got a chance to change something between these two lines or not. If a writer has got a chance to change something between these two lines of code, then better to execute the readlock method. Otherwise, no need to take any lock. Why to take any lock? If nothing has been changed by anyone when you have applied for the optimistic read, then why to take a lock? But if there was something changed between this statement and this statement, then take a lock and do something you want to do. But if there was nothing changed between this line and this line, then no need to take any lock. Just you do your work and come out. So if the validate method returns true, then in that case the thread will not acquire any lock and will do its work without any locking. But if the validate method returns false, then in that case the thread will acquire a read lock and doing its work by printing something. In our case, since all our threads are reader threads, that's why no writer threads can change in between. Therefore, in our case, this if block will never be executed. Now, if the thread which calls try optimistic read does not get the read lock because no thread with the write lock has changed something between this line and this line. In that case, the thread which is called try optimistic read will not get any lock. That's why calling to unlock method by using the reference variable lock in that case will result an illegal monitor state exception. But the same thread may get a read lock also, depending on the value returned by the validate. Therefore, we need to call unlock method in a specific way. First, we need to check each readlock stamp, means the stamp value we are passing to this method, each readlock stamp, is really a readlock. And if it is a readlock, then this method will return true, and in that case, we will call the unlock read method. Otherwise, we will not call the unlock read method. This feature makes the stamp lock very effective in the situation where there are multiple read locks and very few number of write locks. Let's try this code practically. And one more thing, all the codes are given in the video description. Open MyThread.java, and this is the same code as we have seen. Try to compile this code. Java C, CreateThread.java, MyThread.java, compiles fine, now run it. Java, create thread. It runs fine. And you can see the same stamp has been got by all the threads. Rest of the statements have not been printed because, let's see the code, the validation never failed. So this statement has not been printed. And none of the threads ever got the lock. That's why this method call always returned false. The StampedLock method has provision to perform conversion over lock modes. The first method in this category is try to convert to writeLock, which accepts a stamp as its argument. The stamp can be of read mode, can be of write mode, or can be of optimistic read mode. The lock in that stamp will be converted to the write lock. If the stamp represents a write lock, then don't worry, it will be converted into the write lock. If the stamp represents a read lock or optimistic read lock, then that stamp will be converted into the write lock. And similarly, we have to convert to read lock method to convert to optimistic read method. Let's have a read lock and convert it to write lock. So here, first we acquire a read lock. Then after we have called try convert to write lock method with stamp as its argument. And that returns another stamp. Of course, we will print the value of this stamp. If the stamp is not 0, that means the lock has successfully converted to write lock. Then in that case, we have assigned the value of stamp 1 to the stamp. After this statement, we have successfully converted our read lock to write lock. Then after we are calling the unlock write method with stamp as its argument. Since our lock is now a write lock, that's why in this case, calling to unlock write method will perform well and never cause an exception. But if we are failed to convert the lock to the write lock, then this statement will cause an exception. But here in our case, we will successfully convert the read lock into the write lock and we will able to call the unlock write method. So let's try these codes practically. Open CreateThread.java, and this is the same code as we have seen. We are working on the 5 threads, 0 to 4. Open MyThread.java, and this is the same code as we have seen. Here only change is that we are printing the values of stamp and stamp on both. Now try to compile this code. Java C, CreateThread.java, MyThread.java compiles fine. Now run it. Java create thread. It executes fine but not as expected, because the read lock of none of the thread has been converted to the write lock. You can see the value of the stamp 1 for all the threads are 0. What I have noticed here, if the number of threads are more than 1, then in that case, the locks are not converting from read to write. Write here 1, write here 1, and now the code will compile fine and will execute as expected. Compile it, compiles fine, now run it. The code executes as expected. There is only one thread. Initial read lock, the stamp value is 257, then converted to write lock, the value becomes 384, and then T0 finished. So the program is only working with one thread. And if we have more than one threads, then none of the read lock is getting converted to the write lock. Let's open CreateThread.java and use here 2 instead of 1. And again in this case, none of the read lock will be converted to the write lock. Clear the screen, compile, compiles fine, now run it. It executes fine, and none of the two threads, T1 and T0, ever got the write lock. The read lock has not been converted into the write lock. Honestly speaking, I don't know the reason. If you know the reason, then please comment down. Now let's change something in the code once again and make the code to work on just one thread, because it is not working on more than one threads. Let it to make working on just one thread. Open mythread.java, and instead of using here unlock write, let's use here unlock read, and that will cause an illegal monitor state exception, because the lock has been converted from read to write. Therefore you cannot call unlock read. Compile these two codes compiles fine, now run it. It executes fine as expected. The thread caused illegal monitor state exception have not unlocked because there was no read lock. You can try to downgrade the lock, means you can acquire a write lock and try to downgrade it to read lock. Even let's try it and let's check if we can downgrade the locks on multiple threads or not. Let's open MyThread.java and acquire the write lock. Then unlock the read. Of course, we are unlocking the read. Try to convert to read lock. Try to convert to read lock. Got the write lock. Let's open MyThread.java. Sorry, CreateThread.java, and let's first work on a single thread. Then we will change it to 5 threads. Java C, CreateThread.java, MyThread.java, compiles fine, now run it. It executes fine, and the write lock has been converted to the read lock. Let's work on multiple threads. Let's work on 5 threads. 5 threads. Now, try to compile these two codes. Java C, CreateThread.java, MyThread.java, compiles fine, now run it. It executes fine, as you can see. Means with the multiple threads, we can downgrade the lock, but with the multiple threads, we cannot upgrade the lock. With multiple threads, we can go from write to read, but with the multiple threads, we cannot go from read to write. And honestly, I don't know the reason. If you know the reason, please comment. I will pin your comment. There are few more methods present in the StampedLock class, like read lock interruptably. This is the same as lock interruptably method we already have seen. Try unlock write. This method will release the write lock if it is held and returns true if the lock was held. Otherwise, if lock was not held and you are calling this method, then it will return false. After that, we have try unlock write. We have is write locked to check if a stamped lock reference has a write lock or not. Similar to above is read lock, is write lock stamp if the given stamp is a write lock stamp or not. Is read lock stamp if the given stamp in the argument is a read lock stamp or not. Is lock stamp means you can provide any random long number as an argument if that long number is a lock stamp just acquired by any thread or not. Otherwise, there can be a large number of long numbers. You can provide here anything. Is optimistic read stamp if this long number is an optimistic read stamp or not. Then after we have get read lock count, that how many read locks are present in the given stamp lock object. We already have seen such methods with the previous lock classes. So hopefully you got all my points. That's all for this video guys. Don't forget to like and share this video. Subscribe my channel on YouTube, like my page on Facebook, and leave your valuable comments in the comment section below. Thanks for watching. See you in the next video.